Okay, how is everybody doing? Today you are having a lesson on surveys, experiments, and observational studies. Um, it's my first time recording, so hopefully it will go well. Today you're going to learn about different form of statistical research. Statistical research takes various forms depending on whatever the purpose of the research is. There's a couple different reasons. First one is to measure a variable in population. We want to see if there is evidence of an association between two variables, or to determine whether one variable actually has an influence over the other variable. Suppose an example that a graduate school researcher is considering three studies related to math and music. One study involves asking a random sample of high school students in a large, um, suppose a graduate school researcher is considering three studies related to math and music. One study involves asking a random sample of high school students in a large school district whether they listen to music while doing math work. So that's the first study. Okay. A second study involves asking a random sample of students at a large university whether they're majoring in math and whether they also play an instrument or sing. And then we have a third study which involves a group of adult participants where half will be randomly assigned either to listen to classical music for 15 minutes before taking a logical reasoning test or listen to the white noise for 15 minutes before taking a test. So you have one, two, or three. Okay, three different types. The question is, which study appears to look for an association between two variables? So we're looking for the association between two variables without actively manipulating either one. And what are those variables? Okay, so take a look at the three scenarios and ponder for a moment which ones would be looking for the association without actively manipulating either one. Okay, and the correct answer is the second study. The second study looks for association. They're looking at a random number of students asking whether they major in math and playing musical instruments. Okay, so the second, they're asking students if they're majoring in math and whether they're also playing. And I have no idea what's going on. And whether they're playing an instrument. Okay, so we are looking for random number of students. You're asking whether they major in math. And do they play an instrument? What are the variables? Variables is first question is, does student have math ability? And the second variable, the second question is, does student have musical ability? Okay, the next question. which study appears to be looking for evidence that one variable actually influences another variable. So we are looking for the study that would look at um, if one variable actually influences another variable, what are those variables and which one is manipulated to see if it influenced the other. So go back to our three scenarios and take a look, and if you can determine which study would manipulate. And if you stated study number 3, you're absolutely correct. The study number 3 is the correct answer. So the third study looks for random assignment of adult participants and they want to know if they listen to either classical or second is white noise prior to taking logical reasoning test. The variables, we have couple. The first variable is the type of sound listened to. So we had either white noise or music. And the second variable would be the listener's performance on the logic reasoning test. Okay, so we have manipulation, we have random assignment of adults to two different scenarios. Either they're going to listen to classical music or white noise prior to taking the test, and then so our variables are the type of music they are listening to prior to taking the test, and of course their performance. The main thing that you need to pay attention to is that they were randomly assigned. So they were not asked for volunteers. They were basically just drawing the numbers and randomly assigning them. Let's look at the next question. And so the next question says, which study appears to be simply measuring a variable in a population? And then what is that variable? And the study, of course, that's left is study 1. It's asking high school students whether they listen to music while doing homework. So the study number 1. And that study is asking high school students whether they listen to music while doing homework. While doing homework. The variable is listening to music while doing homework. Okay, moving on. So we have some that we need to be able to detect the errors in surveys. So survey measures or characteristics of interest about a population, and we're going to use samples selected from that population. It's very difficult to sample the whole population, so we always find the samples and then try to deduct conclusion about the whole population. There are some rules that apply to sampling, and sample needs to be representative of the population. That's absolutely crucial. So sample needs to be representative of the population in order for the measurement obtained to be accurate, which makes sense. If I am studying the um, homeless population in San Diego, and I do not actively sample from that population, my results will be misleading. Random sampling is generally the best way to endure representation. So random, remember we talked about that, pulling the names out of the hat, randomly choosing people who we're going to survey versus standing in the most convenient place and just asking people who pass by. So, for example, if I send you to survey Steele Canyon students to see how many of them actually have graphing calculators, and instead of randomly choosing students to survey, you stand in front of our class, and as the students exit, you survey how many of them use and have graphing calculator. Your results will be misleading because most of the students in math building are using the graphing calculators. So you have to know the three types of errors. You need to be able to recognize them. You need to be able to describe them on the test. So even if we use the random sampling, and even if we do everything correct, we can have survey errors. So survey errors can be biased questions. So the wording of the question in a survey can influence the way people respond to the questions. So survey questions need to be worded in a neutral and unbiased way. So for example, if you go and survey Steele Canyon students and say, what kind of terrible lunch food do they choose? Word terrible influences that lunch is no good. And so right away it gives a negative connotation. So my suggestion to you is when you read the question right away, first time you read it, it should be like, do you have any kind of feeling of influence, or is it completely neutral? The second error is an interviewer effect. And so biased questions, interviewer effect is the interviewer asks the questions in a survey, and the person being interviewed may give inaccurate response to avoid being embarrassed. So for example, if you're standing next to your mom and I'm doing a survey and I ask you about your first kiss, of course you're going to be embarrassed and you're not going to be truthful. Or if I asked you about your driving habits, do you ever speed or things of that nature, by your mom standing next to you, you are definitely not going to be comfortable answering the question truthfully. The third error is non-response. Some people may be difficult to contact, or they may simply refuse to participate once contacted. If non-response rates are higher for certain subgroups of a population, then those subgroups will be underrepresented in the survey results. And that was evident at last election. They have absolutely miscalculated the representation of college students in the elections. And so when they did their survey, for whatever reason, they did not count the population of the college students and their votes. And so their prediction of the elections were totally skewed. So you have to be able to identify these three errors, and you have to be able to clearly state what the name of that error. So biased questions, interviewer effect, or non-response. Those are the three you need to be able to identify. So we have a next scenario. You need to explain why the results of each survey are likely to be inaccurate, and then suggest the way to improve the accuracy of the survey. So the owner of business conducts interviews with a random sample of employees to have them rate how satisfied they are with their jobs. So the good news is it's a random sample of employees, but what do you think the problem is? Um, who is conducting the interview? And so the owner of the business conducts interviews. So of course, this would definitely be the interviewer effect. And owner conducts interviews of the workers, so workers can fear for job security, so they might not be truthfully answering. And what would be a better solution? So what do you think the better solution would be? To do it anonymous. And find someone neutral person conducts interviews. Okay, someone who doesn't work for the company, someone totally neutral would conduct the interviews. B, in a random sample of town residents, a survey asks, are you in favor of special tax levy to renovate the dilapidated town hall? So as soon as you read this question, do you have any negative connotation? And hopefully you realize that the word dilapidated town hall means that a town hall is in disrepair and that it's not in good shape. So this would be biased question. And word dilapidated influences the response. And basically it's urging repairs. It's falling apart, so that means we need to complete the repairs. So a better way to do it, so better way to conduct this would be make a list of repairs and ask, are you in favor of these repairs? There's a couple other ways to do it as well. So this is not only one correct answer. You can always influence and restate that many different ways. This is just one way to do it, but you always want to make sure you're neutral. So something that will not influence. And also this kind of, I'm hoping that this kind of makes you more aware as you are listening to different surveys, if you are listening to different polls in elections, how are they conducting the survey, how are they asking the questions, and are they manipulating the answers in a way that the question is worded. So you always want to ask your questions. Is there biased questions? Are they biased questions? Is there interviewer effect? And is there non-response? Do we have a number of people who have not been able to participate for whatever reason? Are they properly represented? Okay, let's go to the back. So in the back, it's pretty much common sense. We are dealing with the observational study, versus the experiments, and you need to know the difference. Those of you who had AP Bio definitely had experiments. And observational study, it's mostly used in psychology, or actually in biology, they use it as well. So in observational study, researchers determine whether an existing condition called a factor in a population related to a characteristic of interest. So an observational study might be used to find incidence of heart disease among those who smoke. In a study, being a smoker is the factor and having heart disease is the characteristic of interest. Okay, so they're just observing. They are not manipulating anything. They're just observing and recording. When you're conducting an experiment, researchers create a condition by imposing a treatment. So in order to have the experiment, you have to have a treatment. There's some kind of change going on. There's something that's being manipulated. So for example, an experiment might be conducting by having some people with eczema taking vitamin E and then observing whether the symptoms improve. And in the experiment, taking the pill is the treatment, and improvement of symptoms is characteristic of the interest. So generally, an experiment is preferred over an observational study. Okay, so usually we do want to conduct an experiment, and because one main reason is because the experiment allows researchers to manipulate one variable to see if it affects the other variable. Okay, so the reason experiment is so helpful is because we control the environment so to the best possible way. Of course, there is some I should say unethical reasons against performing an experiment. So for example, it would be unethical to ask people to smoke in order to study the effects of smoking on their health. Or if I want to study the impact of cell phones and death while driving, I'm not going to send you drive down the freeway and text and use your cell phone and see how many of you will get in accidents. That would be unethical as well. So certain things we cannot conduct experiments on, and we would definitely rely on observational studies. So in the next question, we are going to determine whether each research study is an observational study or an experiment. And we're going to identify the factor if it's an observational study, or if it's a treatment if it's an experiment. So factor if it's an observational study, and treatment if it's an experiment. And also we need to identify the characteristic of interest. We need to know what are we interested in studying. So here we go. Researchers measured the cholesterol of 50 subjects who report that they eat fish regularly, and 50 subjects who report that they do not eat fish regularly. So has there been any manipulation, or is this clearly just being observed? And so hopefully you see that this is not an experiment. Excuse me, this is observational study. And the factor is whether people eat fish. So my factor is whether people eat fish. And characteristic of interest is, so characteristic of interest is the cholesterol level. Okay, second scenario. Researchers have 100 subjects with high cholesterol take fish oil pills daily for 2 months. They monitor the cholesterol of the subjects during that time. So hopefully you see that in this case we have an experiment. And the treatment is the fish oil pill. And characteristic of interest, again, is the cholesterol level. So this is a lot common sense. There's few vocabulary words you need to know, but most of it is just being able to um, identify the type of observation or experiment. The next thing is we're going to talk about control group and treatment group in experiments. So whether study is observational or experimental, it should be comparative. Okay, so comparative means we need to compare to establish the connection between the factor of treatment and characteristics of the interest. For instance, determining the rate of car accidents among people who talk on cell phones while driving is not instructive unless you compare it with the rate of car accidents among people who don't talk on cell phones while driving and find that it's significantly different. So we need to be able to compare, always compare to something. In an experiment, randomization can remove the problem of confounding. So in an experiment, randomization can remove the problem of confounding variable by distributing the variable among the groups being compared so that its influence on the groups is more or less equal. So when you randomly assign people in different groups, then you create this randomization so the confounding, the problem will be spread out among all the groups. So the best way to establish cause and effect relationship. So the best way to establish a cause and effect relationship between two variables is to randomize comparative experiment where subjects are randomly divided into two groups which is given the treatment and the control group which is not. So this is very important. So this is like the crucial part of the lesson you need to know. So the best scenario, what you want to do is you want to have cause and effect relationship between two variables. So you need to have randomized, things have to be randomized. You need to be able to compare, and it has to be an experiment. You have to have a treatment, okay? So there are two groups, and one group will be given a treatment, and the other group will be control group. So for example, anytime they do any kind of study with medicine, like drugs, they will have one group that's assigned the treatment, another group that's assigned placebo. No one knows which treatment they're receiving. Doctor has no idea if they're giving their patients medicine or if they're giving them placebo, because the reason behind that is we do not want them, we are human, and we sometimes would treat people differently. So if the doctor would know that this patient is receiving a sugar pill, he might treat this person differently. And so the only person who would know who is receiving the treatment would be the statistician. And that statistician is the only one who would know who is receiving what treatment. And that's why when we do the randomized design, what we usually do is we number. So instead of people's names, people are given numbers, and then they're randomly assigned to different groups. And so there's only one person knows actually who that person is, um, um, the name of that person. So let's look at a couple examples. And so we want to identify the treatment, characteristic of interest, and control group and treatment group for the given experiment. So to see whether zinc has an effect of the duration of a cold, researchers have half of the subjects take tablets containing zinc and at the onset of the cold symptoms, and the other half take tablets without any zinc. The duration of the colds are then recorded. So basically they have two groups. One group is taking the pill, the other person is not taking the pill. And then they measure how long did the cold last. So the treatment So the treatment is take tablets containing zinc at onset of cold, because they have to have a cold, right? So as soon as the cold is coming on, they would give them the pill. The characteristic would be duration of cold, and control group um, would be subjects um, subjects who took tablet without zinc. And the treatment is the pill with zinc. Okay. Let's look at the next example. To see whether regular moderate exercise has an effect on blood pressure, researchers have half of the subjects set aside 30 minutes daily for walking, and the other half do not do any walking beyond their normal daily routines. The subjects also take and record their blood pressure at the same time each day. So the treatment the treatment that they are receiving would be 30 minute daily walk. The character of interest would be the blood pressure measurement. And I want to emphasize, notice when is the blood pressure measured? Blood pressure is measured at the same time each day. So this is another way we are trying at same time each day. And this is crucial. When you conduct an experiment, you want to control as much as you can. And so the blood pressure measured at different times of the day is a different level. So that's why this is important. The control group So the control group has no activity beyond daily routine. So whatever they're doing, walking to the car, walking in the grocery store, walking around the office, whatever they do daily routine, that's part of their daily life. The treatment group walks 30 minutes daily. Okay, so this is it. Okay, so evaluating a media report of statistical research. So this is actually fun. I kind of want you're at a level in your life where you're applying to college, you have had some basic science classes. Hopefully in your other classes you're looking at media and you're online all the time. You're probably not reading the paper daily, but you are aware of different reports and data that's thrown at you all the time. And I would like to challenge you to start thinking a little bit more about the information that comes across your media or daily life. I want you to think a little bit more critical about things that you hear. So when you encounter media reports of statistical research in your daily life, you should judge and reported conclusions on the basis of how the research was conducted. So very rare we hear how did they go about conducting the research. You will hear the outcome and say, "Hey, we found chocolate is good for you. You should eat chocolate." And very rarely they tell you how did they conduct the experiment. So I want you to kind of think about critical about the scenarios. And so if you want to look in the research is a survey, is it an observational study, or is it an experiment? And then ask yourself, do you have enough information? Are you satisfied with that conclusion? Or do you have any questions that maybe you would want to answer to yourself before you come to the same conclusion? You kind of want to know how many people they surveyed, who did they survey, how did they conduct the experiment. And one thing what's important about experiments, once they're published, the research data is published, any scientist should be able to follow the experiment, research paper study, and get similar results. And if they do not, then there's some questions that they are posed at the validity of the research. So right now, there's a huge backlash on vaccinations. A while back, there was a study that was published as a research study that said that there was a connection between autism and vaccination. And a lot of parents were quoting the study and they were not vaccinating their children. Well, as the researchers tried to reproduce that study, they were not able to get the same results. And so what has happened, in the meantime, the researcher admitted that some of the data has been falsified. So this research was not valid, and he got in trouble for it. So this is just one example where you need to carefully conduct the research. You need to ask those questions. So, for example, researchers have found that among patients with cold, those who gave their doctors perfect scores on a questionnaire measuring empathy have colds that did not last as long as and were less severe. Empathy on the part of the doctors included making patients feel at ease, listening to their concerns, and showing compassion. A total of 350 subjects who were experiencing the onset of cold were randomly assigned, okay, so they were randomly assigned to one of the three groups. No doctor-patient interaction, standard interaction, and enhanced interaction. Only subjects in the third group saw doctors who had been coached on being empathetic. Okay, so they were sympathetic towards the patients and they were instructed. So, what do you think? Okay, is it? What do you think of this study? Is it survey, observational, or an experiment? In this case, this was an experiment because you had treatment imposed. So there's treatment that was imposed. So we had situation when there was a standard interaction, no interaction, and then there was enhanced communication. Was randomization used, and randomization was used. So random assignment. So random assignment was used, okay? And they were randomly assigned to different groups. And what details of research does it include? Is anything missing? Okay, so includes number of subjects. So we have includes, we know there was 300 number of subjects. But we have no statistics about how many per each group. So no details on statistic data. So they don't give us any other details, how many were per group and what were the outcomes. We just now know that there was a total of 350 patients. What else we don't know? We don't know duration of the cold. I mean, are we talking about hours difference, a day difference, or are we talking about week difference? And we also do not know the severity. I mean, you can have a sniffle and you can have a cold, or it could be something serious. You can have multi symptoms, etc. So there's a lot of questions that have not been answered, and it's very difficult to conclude, yes, empathy absolutely is shortening someone cold. So this is an example of experiment that they published the data, they gave you the results, but before you run off and say you just need empathy to take care of someone's cold, you do want some other details. You want to always have inquisitive mind and say, hey, how was the study conducted? What did they look at? How is it flawed? Um, and what else would you like to see answered? Okay, so that's about it. Pretty simple, straightforward. Please take a look at the homework. Make sure that you practice using the correct vocabulary. The test, this chapter, it's not difficult. There's very little math. It's more on how are you able to explain? Are you able to use the vocabulary that we have been talking about? So don't forget the 3 errors. You need to be able to explain. You need to be able to explain difference between observation and experiment. And you need to be able to know what's the best possible way to conduct an experiment. What are we looking at? And that's randomized comparative experiment. Okay? Okay, good job. Thanks. And go ahead and start your work on your homework worksheet.